Hello everybody. Today's tutorial introduces the new Sonotest software UTmap. UTmap is part of the newly released Sonotest solution for composite inspection. This solution package is made of three main components: the RS Flight Linear Array Acquisition Unit, the Wheel Probe 2 and the UTmap software. Where the RS Flight and the Wheel Probe 2 are the products for the data acquisition, the UTmap software is for the analysis part of this solution. The software has been specifically designed for the RS Flight product line. However, it is not exclusive to this product line and is compatible with other Sonotest equipment. Now let's start with the software presentation. This is the welcome screen of UTmap. The grey area in the middle is called the T-Scan construction area. This is the main analysis window for this application. On the right, you can see the cursor measurement information window. Directly under it, there is a list of extracted C-scans and the defect dimension criteria section. Finally, under the T-scan window, there is an annotation table. Let's start with the analysis. I'm now going to open some UT files previously recorded with a Wheel Probe 2 and an RS Flight unit. As you can see, the selected file has been added to the next current T-scan view. There are two important analysis steps to achieve a complete analysis in this software. First, the C-scan analysis and then the T-scan analysis. For the C-scan part, the analysis stays more or less the same as in UT Studio. You play with the extracting gate position and level in order to extract the wanted information. And like UT Studio, you can still have access to the soft gain feature in order to adjust your sensitivity after the acquisition. As you may be aware, you can cover a large range of applications by extracting the C-scan information by setting the starting gate just after the interface echo and setting the end gate right after the back wall echo. Once you are satisfied with the current extracted C-scan information, you can send it to the T-scan construction area. To do so, you have two options. The first one is to send your C-scan individually in the T-scan view. This option allows the end user to improve the overall part inspection by optimizing the individual C-scan gatings and reference levels. This is especially useful when the part to be inspected has a complex geometry, thickness variations, or variable acquisition conditions. On the other hand, if such individual analysis is not required, it is possible to analyse only one C-scan and then apply the current gate setting to all the other individual C-scans and extract them all at the same time. The C-scan analysis is done for all the stripes, and I'm now in my T-scan view ready for the second part of the analysis. Just so you know, at all times you can change the C-scan information by getting back into the individual C-scan file and updating the T-scan information. This analysis step allows the end user to do post-acquisition correction by stitching the C-scan stripes together to enable the correct probe starting position and overlap error for a better data overview of the inspected part. This feature greatly improves floor sizing characterization and improves the overall report quality. It is not the case with the current dataset, but sometimes it can be difficult to arrange together. UTmap allows the importation of reference images and CAD drawings to ease the stitching and improve the overall report information. As you can see, having a reference image really helps for the stitching part of the analysis. Once the stitching is complete, it is easier to find defects and measure them in the T-scan view. The ultrasonic information has both amplitude and time of flight information. You could switch from one to the other at any time. The current view is an amplitude representation of the part. Just so you know, UTmap has plenty of colour palettes to use, or you can create your own custom one. Now I just switched from an amplitude representation to a time of flight representation. The scan now displays a whole new set of information. I'm now going to measure one defect in this scan using the UTmap annotation feature. To do so, we need to add an annotation into the T-scan. Then we need to position the box on the chosen defect. Finally, we need to set the defect dimension criteria used in the algorithm to measure the defect. All the defect measurements are written in the annotated table under the T-scan construction area. As you can see, as the criteria is changing, the calculation algorithm is giving real-time visual feedback of the computed area. This greatly improves the reporting quality and the level of confidence towards automatic tool calculation. So you know, in the defect dimension window, it is also possible to combine both amplitude and time of flight criteria for the defected area. Finally, when you are satisfied with the size of your indication, you can export the raw data into a CSV file and generate your report. I hope this tutorial has been useful and that you appreciate this product. Don't forget to contact your sales representative for more information.